Alright, so in the previous video we talked about simplifying radicals using the multiplication property of radicals. In other words, kind of separate and conquer. Whatever the product is in here, we're going to rewrite it as a perfect square times something else. 100 is 4 times 25. It just happens that 100 is 4 times 25. Both these are perfect squares. It's not going to happen that often. In fact, probably not often at all. But we can our goal is to rewrite whatever's inside here as a perfect square times something else. Whether we're talking about numbers like this, these are our perfect squares, and we rewrite like this. Like our 18, square root of 18 is square root of 9 times 2, because 9 is a perfect square. 2 is not. 2 stays inside the house. 9 gets simplified to 3. Square root of 9 gets simplified to 3. We've also got variables. We talked about variables. Perfect square variables are these things in, these things in red. Hang on a second. So those are the things in red that are perfect squares. Perfect square variables have powers that are even. X squared is a perfect square because square root of it is x. X to the fourth is a perfect square because it's even powered. Square root is x squared. So that's the idea. We're going to rewrite variables in terms of square roots of variables in terms of this factor that has even powers. Alright, so that said, here's an idea about simplifying square roots. X to the 7 is rewritten as x to the 6 times x to the first because x to the 6 is a perfect square. Everybody gets their own house. X to the 6 can be rewritten as x cubed squared. Square root of a perfect square means the base comes outside the house. It's the house of square root. So after that, after we took a look at numbers by themselves and variables by themselves, now we can look at maybe numbers and variables together, maybe something like this. But let's build up to it. Let's take a look at square root of 50, just as a reminder. What do we do with this? Square root of 50 is, well, we rewrite whatever's inside the house as a perfect square times something else. So my perfect squares are 1 squared is 1. That doesn't help us. 2 squared is 4. Does 4 go into 50? No. 3 squared is 9. That's the next perfect square up. Let's see, 9, does 9 go into 50? No. Let's see, 4 squared is 16. 16 does not go into 50. 25 is the next one up. 5 squared is 25. Yep. 50 is 25. I'm sorry, 25 times 2. Square root of 25 gets its own house. Square root of 2 gets its own house. Square root of 25 is 5 squared square root of. Square root of 25 is square root of 5 squared. Square root of 2 stays in its own house. Square root of a perfect square means the base comes outside the house times square root of 2. Done. And there's a number. Now, what we can do is put numbers outside the house as well. This just happens to be a 1 that's multiplied by everything over here. So this is also a 1 multiplied by everything over here. And it just happens to be 5 square root of 2 still. Because 1 times 5 gives me 5. If we go up here, now I've got a 5 outside the house multiplied by everything inside the house. And all we're going to do now is, for something like this, separate and conquer. I'm going to have my 5 outside the house. I'm going to have my square root of 24 gets its own house. I'm going to have my square root of 8 to the 6th gets its own house. So all these guys inside the house, we're going to, if it's numbers, we'll give them their own house. Variables, give them their own house. And now take a look at square root of 24. Simplify that. My 5 is still here, multiplied by square root of 24. I'm going to look for a perfect square that 24 can be rewritten as. 24 is 4 times 6. 4 is a perfect square, so I'm going to give 4 its own house and 6 its own house. I'm kind of taking a shortcut here. You could say it's 4 times 6, square root of 4 times 6, and square root of 4 gets its own house, square root of 6 gets its own house. But I'm not, and now I'm going to just continue on with the square root of 4 times square root of 6. Square root of 4 is 2. Square root of 6 is still square root of 6. Square root of 6 cannot be rewritten as a perfect square times something else because 4 is the smallest perfect square or the only perfect square that's smaller than 6. But 4 times can't be multiplied by something, a whole number, to get to 6. So square root of 6 is not a perfect square, cannot be rewritten as a perfect square. So we're done with that one. keep in mind that's 5 times all this stuff. So it's 5 times 2 times square root of 6, and we'll combine everything in just a second. I'm going to take a look at square root of a to the 6th. I'm going to rewrite a to the 6th as a cubed squared, because I want to have a base squared. So now that I've gotten a to the 6th as a perfect square, we know it's a perfect square, because 6 is even. So I'm going to rewrite it as a base squared. Now by square root of a perfect square means the base comes outside the house, so a cubed comes outside the house. So now we take a look at combining everything that's inside the house and outside the house. And I suppose outside the house we want to put everything in the front yard. So let's move this a cubed over to the left and say let's multiply all of the stuff that's outside the house. 5 times 2 is 10. A cubed is a cubed. And 6 is still inside the house. So there's my answer. I've multiplied everything outside the house, put it in the front yard. And then 6 is still inside the house, and there's my answer. 10 times a cubed times square root of 6. Done. And really, that's it. Now, that's about as complicated as we can get. Because we got numbers outside the house, we got numbers inside the house, we got variables inside the house. We can, well, I guess we can get more complicated by saying maybe there's a negative. But what's that negative mean? Well, it's a negative 1 times all this stuff. We got an 81. Now we got 2 variables inside the house. But what does that mean? That means that we give it 3 things their own house. So I'm going to give that guy over here his own space. I'm going to say that's negative 1, if we want to, times square root of 81 gets its own house, square root of x to the 4th gets its own house, square root of y cubed gets its own house. And this is probably about as complicated as we could ever get. I got a negative sign. Square root of 81, well, I know it's a perfect square. I can rewrite it as 9 squared. 81 is 9 squared. All right, so negative 9 squared. Square root of a perfect square means the base comes outside the house. And you could say that it's negative 1 times the 9 if you want. But there we've simplified the square root of 81. But remember, all this stuff is multiplied, so we got to keep all this stuff separate and simplify everything towards the end. Square root of x to the 4th is, well, x to the 4th is x. It's a perfect square, so I'm going to rewrite it as x squared squared. Square root of a perfect square means the base comes outside the house. Okay, x squared coming outside the house. Y cubed, well, it's not a perfect square because 3 is not even, but I'm going to rewrite it as a perfect square. Y cubed is y squared times y to the 1st power. Square root of y squared gets its own house. Square root of y gets its own house. Square root of y squared, square root of a perfect square means the base comes outside the house. This one becomes y. This is square root of y. This is x squared. This is negative 1 times 9. We'll call it negative 9. Keep things in columns. It helps to really keep track of things. All right, now multiply everything that's outside the house. Put it in the front yard. Negative 9x squared y times square root of y is still inside the house. Done. There's my simplification. Let's take a look at that one. Square root of 60x squared. I'm going to cut to the chase. I'm going to give you the answer to this one. I'm going to have you work on it just to make sure that you can get to the answer. This one I'm going to say square root of 60x squared is 2x square root 15. See if you can get to that answer.